Digital transformation is everywhere, and we have seen in the pandemic that people have realized how important the digital tools have become, how important is the automation of the workflows and the processes. And this thing is not going to go away. In fact, the momentum towards digital transformation will keep on increasing. However, the moment we talk about digital transformation, the other word that comes to mind is what softwares to build. Essentially, digital transformation is about putting a lot of software tools and platforms which helps in automation. However, the moment we talk about having a software, the next question that comes is whether to build or buy. And this is a question that is not just becomes very prominent in large enterprise and organization, even at individual levels, like till what point I can manage it myself, or where are the inflection points that I need to go and buy it or maybe get it built from outside. To put this discussion a little bit more context, let me start with a very simple definition of software, that what it means by a software. It's a very simple definition, but this will help us in evaluating some of the inflection points, evaluating some of the trade-offs as we go further into the discussion. So when we talk about software, essentially what I think is software is about that you have some data, or you will be creating some data, and on the other end you have something to handle the functionality, which could be like simple things like creating, updating, deleting those data records and maintaining them along the way. Then there are workflows. Workflows become little more involved in terms of that now the data flows, it has an implication on other data states and things like that. And then there is analytics, looking into the data, trying to find patterns which can help them in making better decisions. And this journey between data and these set of asks that we want to do over data, basically that sort of defines that how simple or how complex the system is going to be. So what you want to do, if you just want to, let's say, do some simple what we call as CRUD operations, create, read, update, delete, with some very simple data points, with not a lot of dependencies around it. You might just want to do some simple transformations which would even involve some amount of simple cleaning, and then you might want to do some aggregation or some sort of that thing to get more insight about the data. So till the context is within these boundaries, the things remain simple. But what happens now when the things start getting more involved? Now you want to get into more complex workflows. Which might in itself involve multiple data points and might also involve a lot of complex state management. Now a lot of decisions you say that would be depending on multiple state of the data points in different parts of the organization. With it come closely is now you have a need of integrations, where you have to basically pull the data from multiple systems to make any sense of it. And it can start getting more and more complex in terms of that now the data point that get involved are much larger, much diverse, and are sitting all across the organization and at times even out of the organization. So if we look into this progression, what happens is that here you have a simple needs which starts becoming complex as you go further and further. So we will work with this simple definition of the software, very elementary things that we have brought here to define the notion of the software. And you might have guessed by now that this is the journey which will also define at times the inflection points where you want to shift gears, where you want to change your approach in terms of how you want to handle your software. So how to approach this whole problem of software, whether to build it or buy it. And as you have anticipated, the first and foremost criteria for decision in any organization, even in personal life, is always going to be cost. Now, how to look into the cost in the context of this problem? Just because the software that you buy shows up a separate line item in your expense sheet and the cost of your internal resources, it is so much embedded inside your whole payroll cost that it's very difficult to attribute what cost you are incurring on different aspects of the team. It doesn't mean that buying a software is costlier than building it. Generally, I've seen an approach in the organizations that they never look after this payroll cost as a cost perspective. But anything that appears as an invoice from the third party takes everyone's attention. I'll leave this here. Okay, now let's come back to our original thing. So once you start building things, and we know that always this progression will define a lot of things. There are things which you can build on your own. You might need to learn a couple of things, and a lot of people do that, which is actually a very good thing, because in this new world of digital transformation, it's very important that we keep increasing our thresholds. And with a lot of tools are also available. There are spreadsheets which work great to an extent. There are now a lot of BI tools which help and increase the threshold further. We have now this low code, no code is coming up, which is further increasing our threshold of what can be done internally. Again, when we talk about low code, no code, you might still need some development background, but I've seen like there are people who take enthusiasm into do that one and go ahead and build it. But what happens is that beyond the point, the amount of effort that you are putting to learn the things and build the things, the ROI will start diminishing. It's always about marginal rate of returns. Beyond a point, it is more important that you invest your time and energy in the functions that you are expert in, rather than trying to increasing your threshold on the direction of the ability to build the software. And believe me, at some point it will just become unwieldy and a lot of frustration starts setting in. So be very careful to what boundaries you want to move the things. And again, building a software is easy. Maintaining a software and improving it further usually becomes very, very costly. Many times people move and then they are married with a set of pieces, a set of things which you even can't make sense of it. The problem with software compared to the other industry is that in software it's very difficult to visualize. If I say that there is a machine, you can see that the machine has like spindles, the machine has a bed, the machine has a motor, and you can make sense of it. But if I say, okay, this is a software which was done by someone, a guy or a girl, couple of years back, and that handles our ERP. Now if you ask, can you please do this small improvement? Okay. So just to summarize, you need to be careful about your marginal rate of return and maintaining a software is real cost, much higher than building cost. There is one more other thing which we should be careful about when we are building software, and this will not change. In fact, it will become more and more complex. Even after so many technologies that would come, we would feel that the threshold of building the software, the ability to build the software will become better for individuals. It's not going to happen, because software is not just about a functioning code. There is something what we call as NFR, non-functional requirement, and here it really needs a good understanding of a lot of software principles. For example, security. We all know that how important it has become. And security is a big thing to get it right in the software. We have issues around performance. Till the data is small, it's fine. The moment data increases, because performance needs a very specialist approach towards building things. Let me give an example of car industry. This industry is there for hundreds of years. The chances of someone building a car at their garage was much higher 100 years back than it is now. Not because you can't build a car which can take you from one place to another place, but you'll spend your lifetime in getting permissions for safety regulations, for emission standards. And the same thing will be happening in the software world also. It's not the functionality part of the software that will increase the complexities, but it will be the another NFR parts, the security parts, the performance parts, reliability parts. These are the things that will make the software building more and more specialized and not the other way around. Now let's look into something which also holds a very big importance in terms of doing this decision, which I call it like knowledge and competency. I'm putting these two words because it's very important that someone who you are intending to build it, even if it is internal or even if you want to outsource it, you need to look into both these words closely. Knowledge is the ability that someone understands it. For example, ERP. Someone understands it, that how a enterprise resource planning happens. But it's also equally important that they demonstrate the ability to convert it into a workable thing. They have the ability to execute it. And what happens is that many times in the earlier discussions, we get carried away the knowledge part of the things and we ignore this thing, and which comes and bites back very hard in the later stages. This very happens with interviews as well. We have seen like folks who do pretty well on interviews, and when put on real ground, they just fumble. And then in this also, I'll put two more sub points. One is the software and another one is the domain. The software part of the things basically tells that they understand how to build the software. But at the same time, it's also is important that the team demonstrates the domain knowledge. And actually, this is the piece that holds a lot of organization to go towards the buy decision, because they feel that it is their organization who understands the domain much better. So involving anyone else is not going to help. So yes, I would not undermine it in any way. In fact, I would not underplay it also in any way. This is very, very important to understand. So whoever you want to engage with, you need to ensure that they understand the domain very well. But at the same time, it's also important that you need to look this with the context of the software competency also. There is again what you need to do for your domain needs to get mapped to make something usable to the software world. And these are again very specialized techniques. There is a whole body of product management, requirement gathering. It is very important that things get built as per the vision. So that's where both this interplay is also very, very important, that the right balance is struck here to get the right things to come out at the end of the funnel. Before we wrap this up, I want to bring one more small aspect of software development, which also becomes very important for the success. So what happens is that how do we build a software? So someone has an idea, has a vision that we need something, some sort of this thing. Then what happens is that you basically collect the requirements and then start building it. But normally people feel that software is like you just think about it and start writing the code. For example, let's take in construction industry. You want to build a house. It doesn't mean that the moment you have started thinking the house, you start putting the bricks on top of each other. It still goes through a process. It goes through an architect, it goes through multiple other agencies in terms of that everything is taken care of, security, safety, fire hazards. So in the same way, software also needs to follow a certain due diligence before you actually start writing your first line of code. So normally I call it like discovery or requirements, and then actual execution. This again broadly comes under in the category of problem definition. And as it is said that a problem well defined is half solved. So make sure that you are spending enough time. Again, I would not hold myself, I would not vouch for these numbers, but generally if you say that if you spend like say 0x time and eventually it takes 10x of the time for the whole software development, then if you spend some quality time in doing the right discovery and requirements, you might be able to in fact reduce it, let's say by make it to 6x. If you make it 2x, it might even come down to let's say 4x or maybe 3x. If you do 3x, you now run the risk of analysis paralysis. You might run into stakeholder frustrations, and even the change of guard might happen, and lost opportunities. So again, you have to strike a right balance also here. You cannot keep doing the analysis paralysis, but again at the same time you don't want to start putting your bricks the moment you think about the new mansion in the island. We'll stop here. Hopefully this is useful, and we'll come with more interesting topics in the future videos. Thanks, take care.